All right, we are still working on Unit 3, and this is Part 2 of our notes. And we're going to talk today about properties of real numbers. Again, you have talked about these properties in previous math classes, but when we begin to work with proofs, you're going to need to state what properties sometimes allows you to make your statement. So we want to get familiar again with these properties of real numbers. And the first one is the commutative property.
I remember these.
Yes, you're going to remember these.
Oh, I hate these. You guys are crazy. These are my favorite things in the whole wide world.
The commutative property of addition and multiplication is the first one we want to talk about. And I'll just abbreviate addition and multiplication. Okay, commutative property. For addition, the commutative property would be A plus B equals B plus A. They just change places. They commute from one place to the other. If we want to look at the commutative property for multiplication, that is A times B equals B times A. When you commute from one place to the other, you move yourself, and that's what we're doing with this commutative property. It just moves from one place to the other. Okay. The next one we want to talk about is the associative. The associative property. And again, that is for addition and multiplication. Associative has to do with grouping. At advisory, you might associate with one group of friends, but at lunch you might associate with a different group of friends. So when we talk about the associative property for addition, an example would be A plus B plus C equals A plus B plus C. That's just an old algebra. If we're thinking about geometry, we might say that the measure of angle 1 plus the measure of angle 2 grouped together plus the measure of angle 3 is the same as the measure of angle 1, and now we can regroup measure of angle 2 plus the measure of angle 3. So that's a geometric application of the associative property for addition. If we want to look at the associative property for multiplication, well, we might have A times B times C equals A times B times C. Just regrouping. And geometric application, the measure of segment AC times 2 times the measure of segment CD is the same as the measure of segment AC times 2 times the measure of segment CD. So just a geometric application of the associative property for multiplication. Oops, I don't need that segment sign, do I?
Wait, what's going on, like, way over there in the yellow? Like, what's the measure of angle 1
That's
plus
measure of angle 1 plus measure of angle 2 plus measure of angle.
That is the associative property for addition.
No, like, what are the numbers?
Oh, I ran out of room. Measure of angle 2 plus the measure of angle 3. Property is, and you use it almost every time you solve an equation, is the distributive property. We use the distributive property a lot.
Okay, this one won't be now, I get all.
but you're gonna be using that all the way through your career, your mathematical career. A times B plus C is the same as AB plus BC. Probably the trickiest thing about the distributive property is if you are distributing a negative, because then you have to remember to change your signs.
Wait, do you mean AB plus AC?
Yes, I did. Thank you. All right. If we're thinking about it in terms of geometry, twice the measure of the sum of the lengths of AB, segment AB, and segment BC is the same as twice the length of AB plus twice the length of segment BC. So these properties of real numbers apply even to geometry. So we need to be familiar with these, that we recognize when we're looking at commutative property. We recognize the associative property, or we recognize the distributive property. Right? So we also have some properties of equality. All right? The first property of equality is the addition property. And if A equals B and C equals D, then we can say that A plus C equals B plus D. In effect, what we've done is add the same thing to both sides. If we want to think of a geometric way to look at that, if the length of segment AB equals the length of segment CD, then we can say that segment AB plus segment EF equals segment CD plus segment EF. We just added the same thing to both sides. Similar property, we had the addition property, subtraction property. And this is a property of equality. If A equals B and C equals D, then we can say that A minus C equals B minus D. Okay. That's just an algebraic way of showing the subtraction property, but if we want to think of a geometric application, if the measure of angle A equals the measure of angle B, then the measure of angle A minus the measure of angle C equals the measure of angle B minus the measure of angle C. Geometric application of that property. Okay, we have the multiplication property of equality. You will be using these properties on today's assignment, the multiplication property, which says if A equals B, then AC equals BC. You're multiplying both sides of the equation by the same thing. These are all properties that you use every time you solve an equation. But if we want a geometric application, if the measure of angle Q equals the measure of angle R, then we could say that twice the measure of angle Q equals twice the measure of angle R. Okay. These are properties that you've worked with so much, they just are second nature, hopefully. And then we have the division property. If A equals B and C is not equal to 0, then we can say that A over C equals B over C. We can divide both sides by the same thing, as long as we are not dividing by 0. Geometric application, pardon?
Wouldn't it still work out even if C was 0?
You can't divide by 0. If segment AB is equal to the length of segment CD, then we could say also that segment AB divided by 2 equals the length of segment CD divided by 2. You cannot divide by 0. You'll find out later that that does strange things to the graph of a function.
Well, I did the thing on the calculator. I did like 64 minus 0 or something. I mean, divided by 0 or something like that, and it gave me like the infinity sign.
Well, it was probably what was happening is it was giving you a vertical asymptote, because if you divide by 0, you're getting unbounded behavior, and the graph would go up or down towards infinity. All right, the substitution property of equality. We did subtraction, but not substitution. You might, and when you're using this on a proof, you can just say substitution. You don't have to write out property of equality. Substitution. But write out substitution, because if you just put SUB, I won't know whether you mean subtraction or substitution. So you can just put substitution when you use this property. But an example algebraically is if A equals B and B equals C, then we can say that A equals C. So a geometric example, if the measure of angle 1 equals plus the measure of angle 2 equals 180 degrees, and the measure of angle 1 equals the measure of angle 3, then we can say that the measure of angle 3 plus the measure of angle 2 equals 180 degrees. That is a property that you'll use a lot in proofs, is the substitution property. We could also say if the measure of segment AB plus the measure of segment BC equals AC, the measure of segment AC, and you know that segment BC, the measure is equal to segment QR, then we can substitute. And we can say that so we have our conditional statement, if then the measure of segment AB plus the measure of segment QR equals the measure of segment AC. So that is your substitution property of equality. Okay, just 3 more properties. Questions on substitution? All right. Now, those are all properties of equality. Move that out.
Just have everyone done.
The next ones we're going to talk about can be properties of equality or congruence, except for the very last one. Okay, so these can be congruence or equality. First of all is probably the simplest is the reflexive property. An example of that is segment DE is congruent to segment DE. Reflexive property. Or angle A is congruent to angle A. You could use it with equality as well. The measure of segment DE equals the measure of segment DE. That's the reflexive property. The measure of angle A equals the measure of angle A. Remember, when we're talking measure, we use equality. When we're talking about the geometric figure itself, or the part of the geometric figure, we use congruence. But the reflexive property can be used with either congruence or equality. All right, the symmetric property. Okay, an example of the symmetric property. If segment DE is congruent to segment FG, then segment FG is congruent to segment DE. They just switch sides of the congruent sign. We could say if angle A is congruent to angle B, then angle B is congruent to angle A. Sometimes we use this one on proofs if we want to just switch the way we said it to make things line up a little better. Okay? You can also use that with equality. If the measure of segment DE equals the measure of segment FG, then we could say that the measure of segment FG equals the measure of segment DE. So congruence or equality. Now the last property is transitive, and that is strictly congruence. And this is just congruence. It's kind of like the substitution property. Substitution property is for equality, transitive is for congruence. If segment DE is congruent to segment FG and segment FG is congruent to segment JK, then segment DE is congruent to segment JK. It's really the substitution property, but for congruence, but we call it's the transitive property. Not we use transitive for congruence, substitution for equality. If angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. Transitive property.